I'm going to do a review of factoring. It's assumed in this class that you've had factoring already, but I just want to refresh your mind on some of this, and then there'll be some homework on this where you can get extra help if you feel like you need it. So it's really important that you know how to factor before we start chapter 7, or you're going to have a really hard time. So if you need help with this, make sure you get the help you need. So there's kind of steps that you follow when you're factoring. The first step is you always look for a greatest common factor. So think of this kind of like as step 1 right here. And when you're looking for a greatest common factor, you're looking for anything that you can pull out that any of the terms have in common. And the way that the order I kind of do this to help remember is look at the numbers first. Is there any number that divides into all of them evenly? Look at your variables. Do they have any variables in common? And if they do, you're taking out the lowest exponent. Okay. And then you look to see if they have any factors in common. By factors, I mean like an x plus 1 in parentheses. So there's a plus or minus sign in between there. So number, variables, factors. And you're not always going to have all three of these. This is just the order that seems to help students when we're doing these. So we're going to start with 3x squared plus 6x, and I always look first to see if there's a GCF. So start with our numbers. What is the largest number that divides into 3 and 6 evenly? And that is a 3. So I'm going to pull that out. And then I look at the variable. I have x squared and x. The smallest exponent is the x, so that's what I'm going to pull out. And then when I first start teaching this, I show that I'm pulling that out, which means I'm dividing both terms by 3x. So at some point, you might not want to write this step, but I'm writing it in the beginning to show you. So pulling that 3x out means I'm dividing both terms by 3x to see what I get. So I'm going to have 3x, and then 3x squared divided by 3x is just x, and 6x divided by 3x is 2. So I get 3x times x plus 2. Okay, so let's look at B. I want to pull out the GCF. So I look at my numbers 4, 16, and 64, and the largest number that divides into all three is a 4, so I can pull that out. Start with our x variable. I have x squared, x to the fourth, and x, so the lowest exponent is an x. And then I look at my y. I have a y squared, and y cubed, so lowest exponent is a y. So again, and this is the part I'm writing in a different color because you don't have to do this part, just showing you pulling that out means I'm dividing each term by 4xy. So I'm going to write this, and then we'll simplify to see what this is. Okay, so I have the 4xy times, when I divide this first, the 4's canceled, the y's canceled, and x squared divided by x is x, plus here, 16 divided by 4 is 4, x to the fourth over x is x cubed, y squared over y is y. Because remember, one of these cancels with one of these 4's. Plus, 4 goes into 64 16 times, the x's cancel, y cubed divided by y is y squared. All right. And that's it. So I just want to remind you, if you are dividing here, like let's say this was 64 divided by 64 and that equaled 1, you can't leave that blank. You do need to put that 1 down. So just be careful with that. All right, difference of squares. It's a formula, and basically says if you have a difference of squares, so a squared minus b squared, so two numbers that can be written as something squared, and then it has to be a minus sign. That's the whole point of the word difference. This does not work for addition. Okay, this is factorable. So draw your two sets of parentheses. And it's basically the square root. So the square root of a squared is a. Then you have opposite signs. It doesn't matter which one you write first. One's positive, one's negative, and the square root of b squared is just b. So this factors to be a plus b, a minus b. And when I first teach this, we talk about FOIL, that if you FOIL this out, you would see when you do that your outside terms and your inside terms cancel. You'll have a negative AB and a positive AB, and that's why this can factor to be a plus b, a minus b. So let's do this first example. If you see two terms, the first thing you should always check is there a GCF? And there isn't here. So then for two terms, this is factorable if it's a difference, which this is, of squares. And both of these can be written as something squared. So again, I'm going to change the signs just to show you it doesn't matter which one you put first. So x squared, it's an x and an x. That's what multiplies to be x squared. And then for 9, the square root of 9 is 3, or 3 times 3 is 9. So this factors to be x minus 3, x plus 3. Let's do the same thing with the other example. There's no GCF, so I'm going to go ahead. This is a difference, and both of these are squares. So x squared, again, I'm going to start with an x and an x and change my signs. For 25 y to the fourth, the square root of 25 is y, and for y to the fourth, it'd be y squared. So it's 5y squared, and that's now factored. Okay, let's look at factoring when you have 4 terms. Okay, so when you have 4 terms, we're going to look at factor by grouping. And we're not going to use this a lot in this class, but I just want to show it to you. The factor by grouping means you are grouping, in this case, the first 2 terms and then the last 2 terms. And make sure when you take the last 2 terms, you take the sign in front of the third term. Okay, and you're basically looking for the GCF. So for these first 2 terms here, I'm looking, change this color, for the GCF of these 2 terms only. And the GCF of 12p cubed and negative 21p squared, the number they have in common is a 3 and then a p squared. And so I'm going to divide both of these by 3p squared, and I get 4p minus 7. Okay, I'm going to now do the same thing with the second 2 terms. I'm going to look for the GCF of just those 2 terms. So 28p and 49, what they have in common is a positive 7, and when I pull that out, I get a 4p minus 7. And you know that you have done this, and it can be factored, is if this factor here and this one here are the same, which they are. I have a 4p minus 7. So I'm going to actually, this is a GCF now that I have. I'm going to pull that 4p minus 7 out, and then I'm going to write what I have left. So if this is gone, I'm left with 3p squared. And if this one is gone, I'm left with a positive 7, and that's now factored. Okay, so let's practice with this next one. Again, I'm going to do the same thing. I'm going to group the first 2 together. I lost that squared there. I'm going to group the last 2 together. So don't forget there's a squared there. Okay, so when I look for the GCF of 24 and 64, I know 4 goes into that. That would be 6 and 16, 8. I believe it's 8. And then r squared. So I'm going to divide both by 8r squared. And I'm going to get 3r minus 8. And here's the thing. You'll know if you didn't pull the largest number out if you have something that still can divide into 3 and 8 evenly, which in this case I don't. It's a good way to always check. Okay, now I look at the next set, and I want, when I pull a number out and I have a parentheses, I want this first number to be a positive 3r. That's the whole point. It should be the same as this factor. I notice I have a negative 21, which means I need to pull out a negative sign to make that positive. And then what do 21 and 56 have in common? It's a 7. So I'm going to pull out a negative 7. When I divide negative 21r by negative 7, I get a positive 3r. And when I divide 56 by negative 7, I get a negative 8. Okay? And I can tell that this is going to work because now both of these factors are the same. I can pull this out. I get 3r minus 8. When I pull this out, I'm left with 8r squared. Over here, when I pull out the 3r minus 8, I'm left with negative 7. And that's now factored. Okay, one of the most important that we're going to spend a lot of time factoring in this class is a trinomial. So that means x squared plus bx plus c. So you have 3 terms. And when the number in front of x squared is 1, like in this example, to factor you need 2 numbers that multiply to give you c and add to give you b. Okay, so you always do check first, do I have a GCF? Because it makes factoring easier. In this case, I don't, so I'm going to go ahead and draw my two sets of parentheses. And I'm going to start with my first term, x squared. That means it has to be an x and an x. And then what you're looking for are two numbers that multiply to be negative 15 and add to be negative 2. So you try different combinations of things that multiply to be negative 15 until you find one that adds to be negative 2. And that happens to be a negative 5 and a positive 3. Those multiply to be negative 15, add to be negative 2. So you have factored this now. Okay, so let's do the same thing with b. Draw your two sets of parentheses. Start with the first term. So we have x squared. That would be x and x. And then again, you're looking for two numbers that multiply to be 45 and add to be 14. So I have two positive numbers here, means these are both positive. And this is 9 and 5. 9 times 5 is 45, and 9 plus 5 is 14. So that's factored. Okay, when you're factoring ax squared plus bx plus c, so that means you do have a number in front of x squared. This is where I use the method trial and error. There are a lot of fancy methods you can use, and if you want to use those, that's fine, but this is the only method I choose or show because the other methods get forgotten. And so I just say, basically, you have to try something and see if it works. So these are the steps I use. Start with your first term, 2n squared. In our case, 2 is prime, so our only option for what multiplies to be 2n squared is 2n times n. So that makes it a little easier. Now look at your last term. You need to figure out combinations that multiply to be negative 9. So my options for negative 9 are negative 9 and 1, or negative 1 and 9, negative 3 and 3. And it's just a matter of where I put the negative 3 and 3. Because my middle term is small, it's a 3, I'm going to start with these two that are closer together, or basically the same number. One's negative, one's positive. You don't know where they go. I'm going to try and get this wrong at first, so don't write this down. Okay, and then here's where you have to check. This is why it's trial and error. You know the first terms are right because you picked them. You know your last term is right. What you need to check, does this outside and inside terms give you that positive 3n you need? So I need to erase this. This is in my way. Okay, so I'm going to check my outside terms. So if I was foiling, this would be my outside, and this is my inside terms. And I need to see what they give me. My outside terms multiply to be negative 6n, and my inside terms multiply to be a positive 3n. And when you add that, you get a negative 3n. So it's close, but it's the wrong sign, and that actually makes this easier. That shows that you have the right numbers, but the wrong signs. So I just need to change the signs of my numbers. Okay, so this is going to become negative, and this is going to become positive. And then when I check, my outside term is positive 6n, my inside term is negative 3n, and that does add to give me the positive 3n I needed. So this is factored now. 2n minus 3, n plus 3. Okay, let's do another example. There's no GCF. Remember, it's always what you're supposed to check first. So I'm going to go ahead and draw my two sets of parentheses. Start with 5n squared. Again, 5 is prime, so my only option here is 5n and n. That's not always the case, but it is here. And then I'm looking at my last number here is 12. So I'm looking for combinations that multiply to be positive 12. And there's a lot. One thing to do that's helpful is look at your signs. It has to multiply to be a positive 12 and add to be a positive number, which means both your signs have to be positive. Okay, so for 12, you have 1 and 12, 2 and 6, 3 and 4, and they could go in either place. So here's the trial and error. You just have to try something. So let's try a 4 here and a 3 here. And then remember, you have to check. I know my first and my last terms are right, but you have to check your outside and your inside terms. So my outside terms multiply to be 15n, and my inside terms multiply to be 4n. If you go ahead and add those, you get 19n, which is what you needed. So we actually factored this on the first try.